Hey everyone! Today I'm diving into something that sounds like it's straight out of a sci-fi movie, building an ionic plasma thruster right at home. Yes, you heard that right. With some basic materials and a bit of engineering magic, you can create your very own thruster. Let's get into it. First off, what exactly is an ionic plasma thruster? Well, it's a type of engine that uses ions to create thrust in space. These are commonly used on spacecraft, but today we're making a simple version. So, what will you need? The list isn't too long. A glass chamber, a high voltage power supply, some wires, and electrodes. Make sure these items are all handled with care, especially when dealing with high voltage. Safety first. Let's start with the glass chamber. This will contain the ionized gas that kicks off our plasma. You can use a simple glass bottle for this. Make sure it's clean and dry. Next, we need to create our electrodes. These can be made from thin copper wires. Shape one into a loop and attach it to the inside of the glass chamber. This will serve as our cathode. Now for the anode, place a smaller piece of wire inside the loop, but make sure they don't touch. Secure everything in place, ensuring there are no loose ends. Next up, connect your electrodes to the high voltage power supply. I cannot stress this enough. Be absolutely sure that the power supply is turned off while you make these connections. Safety goggles on. Once everything is wired up, fill your glass chamber with a small amount of a noble gas, like neon or argon. These gases are inert, which means they won't react dangerously under normal conditions, but they will beautifully illuminate when ionized. Now, the moment of truth. Turn on your power supply and watch as the gas inside the chamber ionizes and creates a glow. This glow is the plasma, and the movement of these ions from the cathode to the anode creates thrust, though it'll be minimal in our homemade version. And there you have it, your very own ionic plasma thruster. It's not going to launch anything into space, but it's a fantastic project that combines physics and engineering for a spectacular demonstration. Plus, it's a great conversation starter or a cool addition to any room. Remember, while it's a fun and educational project, dealing with high voltages and gases requires precautions. Always ensure you're in a safe environment and consider consulting a professional or a teacher if you're unsure about any step. That's it for today. I hope you enjoyed building this thrifty thruster as much as I did. Dive into more projects and keep exploring the wonders of science. Until next time, keep engineering your dreams. Scene 2, Detailed Guide to Building an Ionic Plasma Thruster. Now, let's dive deeper into the specifics of building an ionic plasma thruster. This guide will provide you with a more detailed understanding of each component and step involved in the process. First, let's talk about the design. The basic structure of an ionic plasma thruster includes a glass chamber, electrodes, and a high-voltage power supply. The glass chamber will house the ionized gas, while the electrodes will create the electric field necessary for ionization. When choosing a glass chamber, you have several options. You can use a simple glass bottle, a test tube, or even a custom-made glass container. The key is to ensure that the chamber is clean, dry, and free of any contaminants that could interfere with the ionization process. Once you have your glass chamber, the next step is to prepare it. Clean the chamber thoroughly with isopropyl alcohol to remove any dust or oils. Allow it to dry completely before proceeding to the next step. Now let's move on to the electrodes. Copper wire is an excellent choice for this purpose due to its high conductivity. You'll need to shape the wire into electrodes that will fit inside the glass chamber. The cathode should be a loop that fits snugly inside the chamber, while the anode should be a smaller piece of wire placed inside the loop. Carefully shape the copper wire into the desired forms and attach them inside the glass chamber. Ensure that the electrodes are securely in place and that there are no loose ends. The cathode and anode should not touch each other, as this could cause a short circuit. Next, let's talk about the high voltage power supply. This is a critical component of the thruster, as it provides the energy needed to ionize the gas. When working with high voltage, safety is paramount. Always wear safety goggles and gloves, and ensure that the power supply is turned off while making connections. Connect the electrodes to the high voltage power supply, making sure that all connections are secure. Double check that the power supply is turned off before making any adjustments. Once everything is connected, you can proceed to the next step. Now it's time to fill the glass chamber with a noble gas. Noble gases like neon or argon are ideal for this purpose because they are inert and will not react dangerously under normal conditions. Use a syringe to carefully inject a small amount of the gas into the chamber. Once the chamber is filled with the noble gas, you can turn on the power supply. As the gas ionizes, it will create a beautiful glow inside the chamber. This glow is the plasma, and the movement of ions from the cathode to the anode generates thrust. Observe the ionization process carefully. You may notice that the glow varies in intensity depending on the voltage applied. This is a great opportunity to experiment with different voltages and observe the effects on the plasma. Different noble gases will produce different colors when ionized. For example, neon produces a bright red-orange glow, while argon emits a blue-violet light. You can experiment with different gases to see how they affect the appearance and performance of your thruster. Adjusting the power supply can also affect the performance of your thruster. Higher voltages will increase the intensity of the ionization and the resulting thrust, but be cautious not to exceed the limits of your equipment. Safety is crucial when working with high-voltage equipment. Always follow proper safety protocols, including wearing protective gear and working.